Okay, so once again, welcome to Unit 5. The lesson is on connecting zeros, roots, and intercepts. And so I'll tell you right now that zeros are equal to roots, and roots are equal to x-intercepts. So there should be no surprises from now on in this lesson. Okay? So the first thing we're going to talk about is functions, since the unit is on quadratic functions. And so when we're talking about functions, what we mean is that it's like a relationship between x and y, where for every x, there's one y. Okay? So when you say it like that, it seems really confusing. But if we think about it like in terms of a vending machine, it becomes much simpler. So a function is like a vending machine because if we have one chocolate bar, and we can say it's equal to $1, and we can have a bag of chips equal to $1, and we can have a pack of gum equal to 50 cents. Okay? This makes sense, right? That for every one chocolate bar, it's $1. For every chips, it's $1. For gum, it's 50 cents. So we can say that our chocolate bar, chips, and gum are like our x's, and the price is like the y. So when it's like this, it's like a function. If you were standing in front of a vending machine and you saw, okay, chocolate bars are $1, chips are $1, gum is 50 cents, and then you saw another chocolate bar, the same one, they're both Kit Kats, equal to $2, that would be confusing, right? We'd be like, well, what the heck? Why is it $2? So in a function, we can't have the same thing equal to two different things, okay? Just like in a vending machine, we can't, right? So we can also show this on a graph, which is sweet too. So we'll say our chocolate bars are $1, our chips are $1, and our gum is 50 cents, so it's going to be way down here. And then our line would look kind of like this. Ooh. Right? It doesn't make sense if we have, okay, chocolate bars are $1, chips are $1, gum is 50 cents, and chocolate bars are also $2. Right? You can't draw that graph. It doesn't make sense. Yeah, it's just not a function. It'd probably look like that. Right? So I know it's a silly example, but if you can't remember it, this will help you. Okay? So there's something that we do sometimes called the vertical line test. You might have heard of it in grade 10, and that's when you draw a vertical line going across. So you could draw a line like this. And as long as that line never touches your graph in more than one place, you know it's a function. So for example, if you drew it here, you'd know that it's not a function because it's touching it in more than one place. So does that kind of make sense? It will make more sense as we get going and we start working with it, but we just kind of have to explain it at the beginning as well. So when we write functions, we write them like this, like that. And when we're talking about them, we say f of x or f at x. And when we're writing it in an equation, we write it like this. So what does it look like the f at x is replacing compared to a way we normally write equations? Yeah, exactly. It's replacing the y. And because it's replacing the y, we can kind of treat it a lot like an equation as well. So, for example, if we go down to example 1, the question is, find the zeros of the function of f where fx is equal to 7x minus 21. This find the zeros means that we want to find where the function equals 0. So that means all we have to do is make that equal to 0, and we can write it like this. 0 is equal to 7x minus 21. And so we're trying to find what x makes the entire thing equal to 0. So this is basically just a factoring problem now, right? So we factor it just like we would any other equation. We find our GFC, GCF, greatest common factor. And then from the zero product law, we can go 0 is equal to x minus 3, and then x is equal to 3. Okay. Yeah, you divide both sides by 7. So 0 divided by 7 is 0. So when we're looking for the zeros of a function, it's just like we're trying to solve the equation. We can do it the exact same way, which is awesome. Okay, so we're going to skip the next 2 pages. We're going to go to example 2, the fill in the blank. Yeah, that's why we skipped them. Okay, so fill in the blanks with the statements regarding the function with the equation. So what I want you to write, because this is going to be like important notes. The 0 of the function, the x-intercepts of the graph, and the roots of the corresponding equation, y is equal to 0, are the same numbers. Okay, so this is what I said at the very beginning, where this is what we're learning the entire lesson. It's like the meat and potatoes of the lesson. So if we look at our graph here, we can fill in the rest of the blanks based on just this graph. So, okay, so the graph of the function x squared minus x minus 6 has the x-intercepts. So you can tell me what these are just by looking at it. Yeah, 3, negative 2. 3, negative 2. And what's our y-intercept? Negative 6. Perfect. Okay, so now that's of the graph. If we look at just the function, like that, we know that finding the zeros of the function is just like factoring it like an equation, right? So we would find that these are the 2 factors, and that would give us that zeros are negative 2 and 3. And now, if this was an equation and not a function, so this is like the buddy to the function, is its equation, right? And it's the same thing, you would factor it. So you would go 0, 2. You would go x is equal to negative 2, and x is equal to 3. And this is always true. The function and its like buddy equation have the same roots and zeros, and its graph will always have the same x-intercepts as the rest. So it's a nice way you can check your work by graphing it. If it was a multiple choice test, I'd always be graphing it because it's way easier and faster usually. So that's what we're going to be doing. So if everyone wants to pull up their calculators, we're going to talk about how to find those zeros. So in Y1, what I'd like everyone to do is put 2x squared minus 7x plus 3. Yep, and then press graph, and press zoom 6 as well so that we're all looking at the same one. I think it looks in case you had your window set to something else. Yeah, Zoom 6 just sets it all to the 10 by 10. Okay. So your graph should look something like this. I know I'm no artist, but I'm sure you have a much better picture in front of you. Yeah, HD in real life. So there's two different ways that we can find the zeros or our x-intercepts. So the first one is if you use the zero feature of your graphing calculator. So you can press second, trace, and then 2. And you can use this to find the zeros. So you'll notice at the bottom of your calculator, it should say like left bound, right? That means you want to have your little blinking spider to the left of your intercept, okay? So you want it on this side of it. The left side of the intercept. So you put it on the left side and you hit enter once. Yeah, and then you put it on the right side because it'll say right bound at the bottom. Okay, and then you hit enter again. Okay. So one of them is 0.5. Someone said that one. If you're getting an error, it probably means that you're not moving it between the left and right. So the left, your blinker should be up here, and for the right bound, it should be down here. Where do I find the board calculator? The board calculator? Nope. I'll show it all and then. Okay. So we have our board calculator up. Oh. Perfect. So in y1 we'll go 2x squared minus 7x plus 3. Well, okay. Second trace 2, perfect. So when it's left bound, you can see that my little blinker is to the left of the x-intercept. So I hit enter once. And now it says right bound. So I want to move it so it's just to the right of the x-intercept. And you'll know you're there when the sign of the y changes. Because when you cross the x-intercept, your y is going to change, right? And you hit enter twice, and it'll find it. Okay? So we found 1 is equal to 0.5, and then you also have to go and find the other one. Okay, so same thing, except this time when you're on the left-hand side, your little blinker is going to be in the negative. So you hit enter once, and then right. Okay. If you're, yep, so you get x is equal to 3. If you're getting an error, it means that you're not crossing the x-axis. So make sure your y changes from a positive to a negative or a negative to a positive. Okay, so we'll go. Yeah, 0.5 and 3. So this is the harder way to do it. So I'm going to show you the easier way now, okay? So if you go back to your y's, and you go y2 is equal to 0, and you can make it a fat line too, and hit graph. Okay? Okay. So, okay, grade 11s, I need everyone looking up here. Okay? So, now in y2, I'd like you to put 0, because I'll show you the easier way to do it. Showed you the hard way first, now we're going to do the easy way. Okay? So, does everyone have 0 and y2? Yeah. 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 Same thing in y1, 0 and y2. Okay? So, does everyone have this? Y1 is the same, and y2 is 0 now. Andrew, you have that? Perfect. Okay, so I'll show you how to do it. Just hang on to those hats. Okay, so if you go to second trace and to intersect, and you hit enter 3 times, so enter, 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 you get 0.5. But that's only this intercept, right? And we can see there's another one right there. So you do the same thing, except you want to move your little blinker close to it because it's going to calculate the one that it's closest to. So you want it like right next to it, or else it's always going to just jump to the one it's closest to. And then you get x is equal to 3. Okay? So this intersect way where you have y2 is equal to 0 is an easier way to do it, I find. When I first learned it, I was only taught the 0 way where you have to go, okay, left and then right. But this way with the intersect, I think is easier. Okay, so we know that the x-intercepts are 0.5 and 3 now. And so we can actually use this to help find what our factors are. So we go x is equal to 0.5 and x is equal to 3. And if you subtract this from either side, you can get x minus 0.5 is equal to 0. And then you can do the same thing on this one too. Okay, so all we're doing is we're getting 0 on one side. Okay. So then these become our factors for our equation. So we can go 2x squared minus 7x plus 3 is equal to x minus 0.5, x minus 3. That's a really good question because if these were to be FOILed, what would they equal? X squared? But our equation has 2x squared. So all you have to do is multiply it all by 2. You're going to multiply it by whatever this number is. So if it's a 2, you multiply it by 2. If it's a 4 there, you multiply it by 4. If it looks like this, You don't have to multiply it by anything. You got it. If there was 140 there, you would multiply it by 140. And then because we have a fraction here, I would multiply the 2 through into this, just so that we're working with easier numbers. And then we know those are our factors for our problem. So if you ever have a problem where you don't want to factor the entire thing, you can graph it, find the x-intercepts, and then use those x-intercepts to find your factors. No, you don't have to put the 2 into the second one, because when you multiply these together, that 2 distributes across anyways. Yep.
Here's another way to do this. You just say x equals 1/2, correct? So if I add 1/2 to both sides, or actually, what do I want to get rid of the fraction. I'm going to multiply both sides by 2. So 2x equals 1. Correct? Yes? Yes? So 2x minus 1 equals 0. So that's how you deal with your first with the half. Then you take the other one and say x. Sorry, x is equal to? What's the other one? 3. So I'm going to minus 3 to both sides. X minus 3 equals 0. Now I have my two terms, 2x minus 1, x minus 3. So that's how you can do it right from your graph. Just say x equals a half, get it all equals 0. X equals 3, get it all equals 0. Those are your two terms all the time as well. That's how I do it from the graph. I actually don't do it this way, but from the graph.
Oh, cool. Okay, so we know what our factors are, and we know what our x-intercepts are. So we should be able to know the zeros of our function, right? So what would our zeros be? Remember, if we go to here, the zeros, the intercepts, and the roots are all the same. So the zeros of our function would also be 3 and 0.5. Okay. So we know that there's two methods to finding the zeros. We can graph it, or we can do it algebraically. Like I said before, graphing is great for multiple choice questions, and it's also good for checking your work. But if it was a written response, unless it specifically said use your calculator or graph it, I would definitely do it algebraically. So let's do C. So find the roots of the following equations. When you read find the roots, that's just solving the equation, just like we did in the entire last unit. So if we have 2x minus 8, and we're trying to solve this equation, what's the first step? You got it. Pull out that 2. Okay, and then what else do we notice about it from the last unit? Yeah, perfect. Thank you. And then just like with the previous unit, you can go, okay, x minus 2 is equal to 0, x is equal to 2, and x plus 2 is equal to 0, x is equal to negative 2. Perfect. And then we know that our two roots are x is equal to 2 and x is equal to minus 2. So now we're dealing, in example 5, we're dealing with functions. No, you don't have to verify it because you're not working with a radical. Yeah, so that's a good question. Remember, if it was like this, then you would verify it. But lucky for us, it's not. Okay. So if you look at example 5, they're saying that it's functions and we want to find the zeros. But if you remember, zeros are the same as roots, which is the same as x-intercepts. So when it says find the zeros, you can just make the entire thing equal 0. Okay, so what's our first step? You got it. Okay, and so after we take the 5 out, it's just like a type 1 factoring problem. So what are our factors? Okay, so what two things add together for 3? You got it. So we have plus 4 and negative 1, so x minus 1. And then it's the same thing. We just go x is equal to negative 4, x is equal to 1. So when we're finding the zeros, it's exactly the same as when we're solving for roots. The part 2 to this question, find the y-intercept. It's even easier to find the y-intercept exactly. You put all the x's equals 0. So I usually write it like that. No, you make your x's equal 0. You subtract 20 at the end. So it's negative 20. Yeah, so the y-intercept is always the last thing in the equation if it's all FOILed or multiplied out. So for example, if you look at C here, the y-intercept isn't 1 because we have this here. If you were to multiply it out, it'd be like that. So your y-intercept would be 0. Okay? So yep, exactly. So in this one, y-intercept is equal to 10. Yin. Okay. Pardon? For the first one? Sorry? Yeah, for B, sorry. There. Okay, so if we flip the page, we'll do one last example. So we're going to sketch the graph of the function. So in y1, we can put 4x to the third minus 7x squared minus 4x plus 7. You can for now if you'd like. I know, that's why I chose this one, because it's an awesome graph. Yep, zoom 6 it. Yep. So I'll just pull it up here, Andrew, so you can see. It'll look just like that. Okay. So you can see that now we have a zigzag. So we have 3 x's this time. Okay. So we have one here, and one here. So if you want to put your y2 as a 0, we can use the intersect to find what all of our x-intercepts are. So you go second trace, intersect, and you just want to move that blinker so it's really close to one of them. So for example, I have mine right there. And then you hit enter 3 times. 1, 2, 3. Yep, so one of our intercepts is -1. So you can do it, and so use this to find all 3 of them. Perfect. Okay, so it asks for these in exact values. So 1.75 is 7/4. Okay. So the y-intercept, if you look at our equation here, Justin, what would you guess that the y-intercept would be? Yeah, you got it. So we can... Okay. Okay. Okay, so everyone caught that? The y-intercept is 7, and we know this because if the x's were zeros, this would cancel out, this would cancel out, this would cancel out, and would leave us just 7. Pretty much. We'll learn to do more with them later. You have to know how to do it both, algebraically and graphically. Okay? And so the last part of this question is write the function in factored form. So this is where we use our x-intercepts to find the factors, right? So we go x is equal to -1, x is equal to 2, and we can go x is equal to 7 divided by 4. Okay? We're writing the function in factored form. Okay, so we're using our x-intercepts to find our factors. So we know that it goes x plus 1 is equal to 0, x minus 1 is equal to 0, and then this is the one where we can multiply both sides by 4. So we get 4x is equal to 7, or we can go 4x minus 7 is equal to 0. So what we're trying to do is we're trying to get it so that we have 0 on one side of it, right? Bless you. And then, yeah. Okay. Okay, so we know that our function g, when it's factored, that these are the factors. So we can go, yep, it's just a different name for it, just like how sometimes the textbook will have, so just like, focus for a second, just like how sometimes the textbook will have like A's instead of X's or something, it's just a different way to have it. Okay, and then these are the factors. Okay. Okay. Okay, so are there any questions about this last step? Okay, so how did I get the 4x minus 7 is the question. So if we have x is equal to 7 over 4, we multiply both sides by 4. Or actually, I'm not going to use that. We'll go like this. You could, but you should work with whole numbers, right? Because we still have to get it so that when it's FOILed, you have that 4x to the third, right? Well, you're doing this step if you multiply it by 4 in the beginning. Okay? Yeah, so once we have this is the end of the question. Okay? That's it. That's all, folks. Okay. And then for homework, 1 to 7. No, do 1 to 7. Okay? And we're done.